Hello everyone, good afternoon. My name is Rafaela. I'm from Brazil. I'm a Master of Science from Fluminense Federal University. And the title of my paper is Paleoenvironmental Reconstruction of the Paraúna River Basin, Minas Gerais, Brazil, through phytoliths. The Paraúna River is in the Cerrado. The Cerrado is a kind of savanna that covers about 22% of Brazilian territory and is considered a global biodiversity hotspot. It presents an extreme abundance of endemic species and suffers from habitat loss. From the point of view of biological diversity, the Brazilian Cerrado is recognized as the richest savanna in the world, housing about 11,000 species of previously catalogued native plants. There is a great diversity of habitats which determinate a remarkable alternation of species between different phytophysiognomies. These studies aim to investigate paleoenvironmental conditions and infer possible climate and natural landscape changes, in association with geomorphological and fluvial processes in the Paraúna River Basin, southern Espinhaço Mountain Range, Minas Gerais, Brazil. Soil samples were collected in 6 profiles, 1 per horizon or every 10 centimeters. The profile 1 is in Chiqueiro River, here in the map in black. The profile 2 is in Contagem River, here in red. The profile 3 is in Sepultura River, here in blue. The profile 4 is in Pereiras River, here in green. The profile 5 is a trench on the Cuiabá Road, in purple, right here. And the profile 6 is in Grande River, here in gray. The profile 5 is the only one it's not close to a river. We use this profile to compare with the others. The predominant phytolith types were tracheary, polyhedral, elongate, bilobate, block, and bulliform flabellate, in addition to papillate in floated environments. The tree density index was always low and varies according to migration and displacement of the rivers, indicating that the tree coverage was denser when the river was displaced, suggesting that the limiting factor for vegetation in these areas is not the climate, but mainly the availability of water. The dates range from 70,000 to 1,000 years CalBP. This is the profile 1. We use 3 samples, A, C1, and C2. This is the phytoliths we found in this profile: blocky, elongate dentate, bulliform flabellate, spheroid echinate, tracheary, acute bulbous, saddle, and bilobate. This is a similarity analysis we do with each profile. We separate the profile 1 in 2 zones. Observe. Zone 1 corresponds to horizon C, samples C1 and C2. This is the zone of the profile with the smallest total of phytoliths, and the highest percentage of unclassified phytoliths is observed, which is expected in the deeper zones. Okay, so this is the zone 1, start in the base. According to the time, we saw a change in the results, so we mark the zone 2, corresponds to the A horizon. This zone follows the normal tendency to present the largest total of phytoliths in the profile, but the percentage of unclassified phytoliths continue to grow, which is not expected for a surface horizon. The results suggest that environment gradually become drier. So here we saw the unclassified is still high, and the index BI. This is the profile 2. We have 4 samples, A1, A2, E, and BH. This is the phytoliths we found in profile 2. Blocky, Buliforme flabellate, Elongate dentate, Spheroid ornate, Spheroid echinate, Bilobate, Saddle, and a megascleral sponge spike fragment. Indicates the presence of water. This is the similarity analysis from profile 2, and we mark 3 zones. So, the zone 1 from 70,000 years ago, called BP, sorry for the IP, it's BP, corresponds to the horizon BH and E. From the base to the limits of the zone, there is an increase of the total of phytoliths. Horizon E has the largest total in the profile. It is a percentage of confiable phytoliths classified in the percentage of classified phytoliths and the PAP index. The DP decreases, indicating that the higher production of phytoliths come from grasses. So, here's the zone 1. Sometime after, we mark the zone 2 in 170 to 158 years, called BP. Corresponds to A2 horizon. Is the smallest total of phytoliths in the profile, while the DP and PAP index are the largest, indicating an increase in tree cover in the region during this period. Probably because the wood plants present in this area produce few phytoliths, or they are not preserved in the ground. Then we mark the zone 3, corresponding to the A1 horizon. The DP decreases again, reaching the bottom of the profile, unlike the total of phytoliths, which increase considerable. The PAP also decreases a lot, reaching almost zero. The BE index tends to decrease in all zones. These results indicate a possible increase in moisture of water available in this environment. Here is the profile 3. There's 4 samples. See, it's not collected. A1, A2, A3, A4. This is the phytoliths we found in profile 3. Buliforme flabellate, blocky, elongate entire, elongate dentate, tracheary, spheroid ornate, spheroid echinate, acute bulbosus, bilobate, cross, and saddle. This is the similarity analysis from profile 3. We mark also 3 zones. Zone 1 from 430 to 7,180 years, called BP, in 140 centimeters depth, correspond to the A4 and A3 horizons. Here, the zone 1, A4 and A3 zones. From the base to the limit of the zone, it presents a marked growth in the total of phytoliths, reaching the highest profile in the A3 zone, which is not expected in the deeper horizons. Despite increasing the total of phytoliths, there is a decrease in classified phytoliths. So here we saw the classify, and here we saw the total of phytoliths. It's not a normal tendency. Zone 2 corresponds to the A2 horizon. The dP and total of phytoliths are the lowest in the profile, while water stress is the highest, indicating a reduction in moisture and water availability from 920 years called BP. Here we saw the BI. Here we saw the DP. Okay, and the small total of phytoliths. Zone 3 corresponds to the A1 horizon. The dP increases again. Here, increases again, getting very close to the value it had in Zone 1. The PAP also shows a large increase, reaching the maximum value of the profile. These results indicate a possible increase in moisture or water availability in this environment. The particle size remains similar to that in the anterior zone. This is the profile 4. We use again 4 samples. This is a stone line not collected from phytoliths, and the horizon C also not collected. We have sample A, B1, B2, and B3. This is the phytoliths we found in profile 4. Blocky, bulliform flabellate, elongate dentate, papillae, spheroid ornate, bilobate, polylobate, e acute bulbosus. This is a similarity analysis from profile 4 with 2 zones. Zone 1 corresponds to horizon B, samples B1, B2, and B3. From the base, the total of phytoliths and the organic carbon tend to increase continuously, reaching the maximum values in sample B1. Here we saw the total of phytoliths and organic carbon. Zone 2 corresponds to the A horizon. These zones present a decrease in the total of phytoliths in relation to the B1 horizon, but the percentage of classified phytoliths remains high. The dP index decreases towards the surface, as well as the total of phytoliths, carbon, and BE index, showing an inverted tendency to zone 1. So we saw the degrees here and here, the dP, and the opposite in PAP and BE. This is the profile 5. We have the samples A, B1. This is a stone line we found in the middle of the profile. Then B2 and BC. The horizon C is not collected. This is the phytoliths we found in profile 5. Blocky, bulliform flabellate, bilobate brown, bilobate, blocky brown, elongate entire, elongate sinuate brown, saddle, cross, spheroid ornate, papillae, acute bulbosus. This is the similarity analysis from Profile 5, with 3 zones. Zone 1 corresponds to BC and B2 horizons. From the base to the limit of the zone, there is a marked growth in the total of phytoliths, reaching the highest profile value in the B2 horizon, which is not expected in the deeper horizons. So, here we have the highest value in B2 of the total of phytoliths. Zone 2 corresponds to the stone line. The DP and the total of phytoliths are the lowest in the profile, while the water's stress remains almost the same in the previous zone. Here, BI is almost the same. We have a small DP and here the smallest total of phytoliths. Zone 3 corresponds to the B1 and A horizons. This zone is similar to those observed in Zone 1. The DP index increases again, while the BI index tends to decrease. These results indicate a possible increase in humidity or water availability in this environment. Here we saw the BE, the DP in the opposite, and the total stay small. Finally, this is the profile 6 in Grande River. We have 4 samples, A, B, C1, and C2. This is the phytoliths we found in profile 6, blocky, bulliform flabellate, cross brown, bilobate, spheroid echinate and blocky, spheroid ornate, elongate entire, spheroid piscillate. This is the similarity analysis from profile 6 with 2 zones. Zone 1 corresponds to the horizon C, sample C1 and C2 here, and zone 2 corresponds to the horizons B and A. In the zone 1, we have the lowest percentage of organic carbon, total of phytoliths, and the highest percentage of unclassified phytoliths, which is unexpected to a deeper zones. The DP is too low and BA is too high. Here, BI too high and total classified, unclassified, and DP too low. In the zone 2, we saw the largest total of phytoliths in the profile, following the normal tendency in 2 degrees with the dips and percentage of classified phytoliths continue to grow, which is expected from the most shallow horizon. Here we saw the total grow and the classified and the DP. So, many results obtained need to be complemented or clarified, and formulate hypotheses still need to be tested and deepened to be confirmed. Thus, it is understandable that the completion of this work does not mean the completion of the studies in the region. Elementary phytoliths, carbon and nitrogen analysis has shown to be very promising in the understanding of geomorphological evolution, environmental change, especially when associated with other indications such as granulometry. Thank you so much. For more information or questions, please contact me by email. Rafaela. r.dias@gmail.com. Thank you.